In today's lesson, we're going to talk about how to estimate values on a curve using tangent lines. All right, so you can see here in number 1, the directions say, using the given point, which is the point 6, 5, that's where they come together, and the tangent line shown, that's in blue, estimate the y-coordinate of f of 8. F of 8 on the red curve, we don't know what the y-coordinate is. And there's no way to find out because I didn't give you the equation of the curve, of the parabola. So instead, we're going to use the tangent line. Okay, first things first, we're going to find an equation of the tan line. Since the line is in blue, I'll use blue to do this, and I'll use point slope form. You can see that the point of tangency is 6, 5. The x is the 6. The y is the 5. And of course, anytime you're inside parentheses, brackets, or bars, you always go opposite sign, so hence the negatives. And we have the slope already. It's 7/4. That goes right here in this gap. And that gives us the equation of the blue tan line already, which is great. Now, to figure out what we're being asked for, let's go ahead and take the 8, because we want to find f of 8. And we'll plug the 8 right in here where this x is. In fact, I'll just change it to an 8. That's pretty slick. 8 minus 6, that'll be 2. Bring down the 7/4. I can see some slight canceling occurring here. So we're going to have y minus 5 equals 7/2, which is 3.5, say 3.5. And we'll add 5 to both sides. And y is 8.5. So f of 8 is approximately 8.5. Okay, so the first part of the question has been answered. The question goes on to say, is your answer, the 8.5, an overestimate or an underestimate of the actual answer? And in this case, it's an underestimate. Here's how I know. This 8.5 that we got by using the line. So on the line right here, that's the point 8, 8.5. You can see that the real answer is slightly above, so the 8.5 is an underestimate. It does say explain how you know, so I'm going to say because, and the reason is very simple. The curve is concave up. The line is simply straight, as all lines are. So you simply need to say because the second derivative is positive. Don't say concave up, even though it is. Mention second derivative being positive or greater than 0. That's all you have to say. But you want to work that double derivative in. That's what College Board is looking for. All right, so f of 8 is about 8.5. It's an underestimate of the real value because the curve is concave up, meaning the second derivative is greater than 0. Okay, that's number 1. Let's try a few more. This time we want the y-coordinate of f of 2, so 2 comma what? Okay, here in number 2, we're looking for the y-coordinate here, 2 comma y on the curve. We don't know what it is, so let's start with the tan line instead. So again, we'll use the point of tangency, which is the 1 comma 9 that you see right there. That's where they come together. We'll write y minus 9. The slope we know, it's negative 3/2. It's been given to us. And x minus 1. Again, the 1, 9 coming from the point of tangency right here. And since we want to know f of 2, we can just simply take the 2 and plug it in right here. Now, unfortunately, that's not going to put us where we want to be. It's not going to put us on the curve. It's going to put us right here on the line. But that's okay. It's not too far away. Let's see what we have. Y minus 9 equals negative 3/2. 2 minus 1 is 1, so I don't even need that parentheses. And y is going to be, let's see, that's 9 minus 1.5. That's going to be 7.5 or 15/2. So f of 2 is approximately 7.5. So actually, the point 2 comma 7.5 is not really on the red. It's really that blue point. You can see that our estimate of 7.5 is an overestimate of what it really should be. And that's because the curve's concave down. So again, I just simply need to write it. But again, don't say concave down. Say the second derivative is negative. And that's it. Okay, number 3, it says, let y, also known as f of x, be the particular solution to the differential equation. All right, we have not formally learned differential equations yet. We will a little bit in Unit 4 and mainly in Unit 6. So we haven't seen these. And there are ways to solve them. There's whole courses on differential equations in college. We don't need to solve this, though. It just simply says write an equation for the tangent line. And then use this tangent line to approximate f of 1.1. So let's go ahead and see what we can do. I am focused right here on this statement. Write an equation for the tan line. So immediately I go into my safety mode, which is point slope form. We're looking at the point 1, 0. It's mentioned a couple times. X is 1. Y is 0, which means really the left side is just going to be y equals. And I need the slope to go into that gap right here. And slope is synonymous with first derivative. And the first derivative is given to us up here, dy dx. So let's put the 1, 0 in. Remember, 1 is the x, 0 is the y. So the slope is going to be e to the 0, which of course is 1, which I don't need. And then the parentheses will be 4 minus 6, which is negative 2. So there's the equation of the tan line. Let me just bring it over here and neaten it up a little bit. So that's perfectly fine. That's the tan line. That's the first part. And then it says use the tan line to approximate f of 1.1. The reason I left it factored is I think it's easier just to plug the 1.1 in there. Makes the parentheses 0.1, or just 0.1, times negative 2. That's going to be negative 0.2. And there you have it. Number 3. All right, this will be the last problem in the section. It's making me hungry. We're talking about pizza coming out of the oven at 425, which is usually what I cook it at. And I want to eat it right away, but I always burn my roof of my mouth. I'm impatient. I need to just chill for a while and let the pizza chill. It says the temperature of the pizza remains greater than 72 degrees Fahrenheit for all times t is greater than 0. To me, that means that we're taking it out and putting it in the room, and the room is 72 degrees. The pizza's never going to go below that because even 4 days later, it's room temperature. Here's the formula for how the pizza is cooling, because notice it's a differential equation. It starts with a derivative, which is a rate. Derivatives are rates of change, as we know. Okay, and it says temperature at time 0 is 425. We knew that already. Part A says write an equation for the tan line at time t equals 0. And then once we write that equation, we're going to use it to figure out an approximate temperature for the pizza 5 minutes later. Maybe I'll be able to eat this thing. All right, we're going to take this this point, which is really the point 0 comma 425, and we're going to put it in the point slope form. So it's going to be t minus 425, capital T for temperature. We'll use lowercase t for time. I wish they were different letters, but they're not. I can't control that, so not a big deal. And again, the slope, or the rate of change, it's going to go in the middle, and that's the derivative. So to figure that out, I have to say, all right, time is 0. If time is 0, then this capital T for temperature is going to be 425. So 425 goes in there. 425 minus 72 is 353. Sorry, I'm doing a little mental math here. We've got a negative out front. That's 18/100ths. That's 9/50ths Okay, you know what? So much for mental math. I'll grab my calculator here, and that's going to be negative 63.54. Okay, so I've got the equation for the tan line. Now I need to use this equation and figure out how warm the pizza is 5 minutes after coming out of the oven. Well, 5 minutes later means that lowercase t for time, is 5, so put a 5 in here. Again, I can just use the calculator at this point. And the temperature of the pizza at 5 minutes, I'll write it properly here. I could probably eat this thing now. That's going to be 107.3. Again, we always want to use units. That's degrees Fahrenheit. It's higher than body temperature at 98.6, but probably not hot enough to burn the roof of my mouth, so 5 minutes, I'm good. I'm eating. Okay, this last question has a part B. Let's see what they want. Same pizza, same situation. This time it says use the second derivative, that's what that means, to determine whether your answer in part A, which is the 107.3. By the way, if part A is wrong, College Board still cuts you a break, and they will use your wrong answer and grade it as if it was correct on part B, which I think is very student-friendly, very kind of them. By the way, I made this problem up. This is my original. So, all right, use the second derivative. Determine whether the 107.3 is an overestimate or underestimate of the real temperature of the pizza. Okay. Well, let's find the second derivative. The second derivative is the derivative's derivative. So let me take this down, and I'll take its derivative. First, I'm going to kind of just think outside the box. This is going to be negative 0.18t plus some number I don't care about because its derivative will be 0. So when I go to take the second derivative, a very strange notation, by the way, nothing's being squared. That's just going to be negative 0.18. Oh, but that was the wrong letter. It was supposed to be time, and this is capital T for temperature, so I need an implicit parentheses chain rule thing here. I need dt over d little t. Oops. Okay. Wow. Now again, this seems to be a little confusing, but I don't think it will be once you realize something. And here it is. This sentence didn't seem to be real important at first, but the pizza's never going below 72 degrees, which means that this parentheses right here is going to stay positive the entire time. Unless you forget about the pizza and a couple weeks go by, then it'll be 0, but it's never going to be negative. Okay, so if the parentheses is positive, we don't even really care what it is. That means that the entire thing with an extra 0.18, negative 0.18 in it, is going to be negative. So in other words, let me show you what I mean here. This comes down. When I go to rewrite the dt over dt, it's going to be this. I'll just write positive. And you can see that we have negative times positive. That's positive. And if the second derivative is positive, that means that the curve is concave up. The curve's going to look like this. On the curve, we had the point 0, 425. That was the pizza coming directly out of the oven. Later on, I used the tan line to find that after 5 minutes it was at 107.3, but the tangent line is just that. It's a line. And so 5 minutes later, I'm at 107.3, but the real temperature of the pizza is here at 5, we don't know, and we'll never be able to know. But my 107.3 is an underestimate. Why? Because the second derivative is greater than 0. that's it for number 4. In fact, that's it for section 3G, estimating values of curves using tan lines. Hopefully it made sense to you, and have a good day. We'll see you next time.